Water locating for water wells. Almost everything you would need to know before having a water well drilled. You will be paying from $15,000 to $50,000 plus on a well system, depending on the driller you use. This PowerPoint is extensive, a wealth of knowledge. Peek into the well drilling industry, do's and don'ts. Table of contents for ease of navigating. Click any slide to review. Scroll up and down. With this information, you can make a more informed decision. This PowerPoint covers all the main questions that I still continually receive over the past 23 years. Water locating for water wells. Where should I drill? What method should I use? Geology, geophysics, visual site selection, water witching, dowsing. American water wells, radar water geophysics, aquifer geometrics. This is the aquifer. This is the heart of the aquifer. Computer-generated targets produce more gallons per minute at less depth in drilling equals savings $2,500 for each 100 feet not drilled. Savings 40% average in pump equipment. Average depth of well 200 to 500 feet on a computer-generated target. Savings 50% average in electric bills. Visit webpage for more information, waterlocating.com. If you spoke to 3 water well drillers, you would select a driller that convinces you more so that he will get you the water. If so, then ask the driller, how much water will I get and how deep will the well be? No water well driller knows where the better place to drill is. Wherever you drill on Earth, you will receive some water, something, or just squat. Some drillers will recommend a water witcher, etc., to keep the liability off of them. The consequences of drilling blindly will be yours. Proceed slowly. This is a cross-section of an aquifer system, a vertical slice of the earth. With an X-ray of a broken bone, white represents hard bone, black is a fracture. This cross-section of an aquifer, white represents hard rock. Black is a fractured, porous zone. Your well should be drilled here, in the major fractured black zone. Why? Big water collects in major fractures. At 50-foot intervals, we make electronic soundings across your parcel. measuring the geoelectric signature of fractures. Generating these vertical slices called cross-sections. Like an MRI produces a picture of the inner body, we produce a picture map of your aquifer system, identifying the more fractured, porous zones where water would collect. A mathematical formula generates the cross-section, a graphical illustration of the raw data representing the subsurface geometries of rock volumes, providing a highly accurate chart of underground strata. Cross-sections reveal the presence or absence of geological formations, similar to those that have historically produced volumes of water at shallow depths. These rock volumes have different degrees of density. The blacker shades are more fractured porous than the whiter shades. These shades of gray represent minor fracturing and porosity, which are seen everywhere throughout the earth. So wherever you drill on earth, here, you will receive some water, but the best place to drill is within major fractured zones, here. Vertical cross sections are likened to slices of a hard-boiled egg. Pull aside one slice and you see some yellow, the shape of the yolk. Pull aside additional slices and the yellow becomes larger, then smaller. Viewing these cross sections, you can see the geometry shape of the yolk. With our geophysical cross sections, we see the geometry shape of your aquifer. From these cross sections, you see the fractured porous zones of your subsurface. The best place to position your new water well is here. In the pooled zone of major fractured earth. Swirling around a rock volume, the white shades. Extending along the right side to another pooled area. Here, within the yellow semicircles, you can see a trough-like zone on top of a hard rock formation. You can drill anywhere on Earth and hit water if you drill deep enough. Here, here. Fractures are everywhere. Best to drill into major fracturing. The aquifer's heart, here and here. These darker zones have produced yields from 15 to 500 gallons per minute, within 200 to 600 feet in drilling depth, around 90% of the time. No need to drill 800, 1000, or 1200 foot plus dry or low producing wells. These high yield wells will be seen in upcoming testimonials. Fractures here are tilting 45 to 75 degrees. This picture shows the general tilt of fracturing. If you see a section of earth cut away for a roadway and there is visible strata, it always tilts. Strata never goes straight down into the earth. Here, visual site selection within the valley looks really good for the placement of a water well. The yellow arrow points to a power pole for the old well with only a 3 to 5 gallon per minute output. The computer identified the tilt of subsurface fracturing in the valley, tilting to the left. Drilling into this fracture system generated a yield of 50 gallons per minute. Question: where do I drill? On a computer target or driller's suggestion? Again, visual site selection within the valley looks really good for the placement of a water well. The green arrow points to a power pole for the old well with only a 3 to 5 gallon per minute output, 150 acre grove. Over here I drew in a valley outlined with trees, with a blue line representing the contour of the valley. This blue contour line is transposed onto the picture of the valley. Here, the computer chart shows the heart of the aquifer is tilting away from the valley bottom. The 4 blue arrows define the tilt of fracturing. The well should be drilled at the yellow-red arrow to intersect the heart of the aquifer. Transposed over here 200 to 300 feet away from the valley bottom. Drilling results equals 50 gallon per minute flow rate versus 3 to 5 gallon per minute output. The computer identifies the tilt of the strata 100% of the time. Aquifer geometrics. No driller, no witcher, no chicken bone. No dowser, no old Indian, nor geology, or visual site selection compares to computer imagery for the placement of your water well. For high-capacity water wells, you need to drill into highly fractured systems. Big water only collects in major fractures. This is the aquifer. This is the heart of the aquifer where water flows more freely due to major fracturing, highly fractured zones. The heart of the aquifer is normally 3 to 500 feet in depth. From the heart, fractures extend downward 45 degrees. As fracturing extends downward, away from the heart of the aquifer, fractures become less and less. So, the farther away you drill from the heart of the aquifer, the deeper you would have to drill, hoping the drill stem will intersect a fracture at depth containing water. Many non-productive wells extend past 600 feet down to 800, 1,000, 1,200 feet, even down to 1,600 feet. Most deep wells are non-productive, very expensive to drill, and the cost of electricity is more than the price of water. When an aquifer system passes through your parcel, we will see it, identify it 100% of the time. For a productive water well, you need to drill into the heart of the aquifer or as close to the heart as possible. If no aquifer passes through your parcel, do not drill. Do not purchase the parcel. Advantages drilling into the heart of the aquifer. Save in drilling expense, 65% plus. Save in pumping, electricity costs, 50% plus. You could receive 100% plus more water in gallons per minute. For each 100 feet not drilled, you save $2,500 plus. Do you really want to drill blindly again? 1,200 feet? 80% of wells are poor. See Part 2. I never should have listened to the driller. Forgive him. He knew what he did. Important notes. Computer-generated targets are hard to drill on, but major fracturing is where the water is. Drilling within major fracture zones, many drillers are out of their comfort zone. Most drillers do not have the talent to develop a computer target to full gallon per minute capacity, so they will use any conceivable excuse to discourage the use of the computer. Discourage drilling on a selected computer target by moving off the target to a degree or making false statements. Recommendations carry a lot of weight. Drillers know this, so for them to have a fair shot at drilling your well, they try to discourage the use of the computer, for we do not recommend most drillers in your area of Riverside or San Diego counties. Drillers do not want to drill shallow wells. There is more money in drilling deep wells. A lot more. Reasons for not recommending certain drillers. being dishonest with prospective clients, making excuses not to drill to depths like we hit hard rock. If we drill deeper, you may lose the water you have right now. Stopping the drilling too early, avoiding a difficult site to drill on, supporting water witching, EKS, etc., when they know it is basically ineffective, wanting to drill blindly to drill extra deep holes, making false claims of a lot of water if we drill with a bigger diameter bit, not having a suitable drilling rig to drill through water zones for maximum production. To be more informed, see other knowledgeable PowerPoint videos on water locating, water witching, dowsing. Learn what it really is. Water locating, EKS, do's and don'ts. Electroseismic, now termed seismoelectric, SES, originally known as electrokinesis.